Hello everyone. In this video, we will learn to define enthalpy change of a reaction or process and relate it to the change in internal energy. To associate the sign of delta H with exothermic or endothermic processes. According to the first law of thermodynamics, the internal energy of a system can only be changed in two ways, by heat transfer or work done. Now, if the only type of work the system can do is pressure volume work, the work done in the formula can be replaced with minus P external delta V. If a process or chemical reaction occurs at constant volume, then delta V, which is V final minus V initial, will be equals to 0, which means the work done during the reaction or process is 0 and the change in internal energy of the reaction is equal to heat absorbed or released in the reaction. That is, delta E is equal to QV, where QV is heat transferred at constant volume. So, if we want to measure the change in internal energy of a reaction, we perform that reaction in a sealed container at constant volume and measure the amount of heat released or absorbed during that reaction. However, most of the chemical reactions in the lab occur in open containers or test tubes at constant atmospheric pressure. Therefore, scientists proposed a new function or property called as enthalpy to better define the energetics of these chemical reactions that are happening at constant pressure. Enthalpy is represented by letter H and is equal to E plus PV. Since the internal energy, pressure, and volume are all state functions, enthalpy is also a state function. Similar to internal energy, the absolute enthalpy value of a substance is very difficult to measure. Again, fortunately, we are not interested in measuring the absolute enthalpy of a substance. What we are interested in is enthalpy change of a reaction or process. Let us consider a chemical reaction or a process in which reactants are converted into products. Since enthalpy is a state function, we can write that the enthalpy change of this reaction or process is equal to the total enthalpy of products minus total enthalpy of reactants. We know that H is equal to E plus PV. Delta H will be equal to delta E plus delta PV. As discussed earlier, majority of the reactions in the lab occur at constant pressure. So, if pressure is constant, then we can take the pressure term out of the differential and write delta PV as P delta V. Let us plug this value into the enthalpy equation and simplify it. We get delta H is equal to delta E plus P delta V. So, the change in enthalpy for a reaction or process is equal to the change in internal energy for that process plus the amount of pressure volume work done during that process. Next, we will learn how to measure the enthalpy change of a reaction in the lab. Delta H is equal to delta E plus P delta V. We can replace delta E by Q plus W. And if only type of work done by the reaction is pressure volume work, the work done term in the formula can be replaced with minus P delta V. That is, delta H is equal to Q minus P delta V plus P delta V. These two terms get cancelled and we can write delta H is equal to Qp, where Qp is heat transferred at constant pressure. So, for a reaction or process that occurs at a constant pressure and in which only work that is allowed is the pressure volume work, the enthalpy change for that reaction or process is equal to the heat energy absorbed or released during that process. This is why the enthalpy change of a reaction is also called as heat of reaction. Since majority of reactions occur at constant pressure, for these reactions, delta H is more relevant than delta E. So, to measure the enthalpy change of a reaction, we conduct this reaction at constant pressure and measure the amount of heat absorbed or released, that is Qp, during the reaction. Later in this chapter, we will learn how to measure the enthalpy change of a reaction experimentally. This technique is called as calorimetry. In this slide, we will learn how to identify if a reaction is endothermic or exothermic from the enthalpy change value. Delta H, enthalpy change for a reaction or process, is equal to the heat transferred at constant pressure, which is equal to the total enthalpy of products minus the total enthalpy of reactants. If the total enthalpy of products is greater than the total enthalpy of reactants, then change in enthalpy is greater than 0 and the reaction is called as endothermic reaction. An example of an endothermic reaction is photosynthesis, in which 6 moles of carbon dioxide gas reacts with 6 moles of liquid water to form 1 mole of solid glucose and 6 moles of oxygen gas. For this reaction, the change in enthalpy delta H is equal to 2.80 times 10 to the 3 kilojoules per mole of glucose. That is, the combined enthalpy of all the products is greater than the combined enthalpy of all the reactants by the amount equal to 2.80 times 10 to the 3 kilojoules. Conversely, if total enthalpy of products is less than the total enthalpy of reactants, then delta H is less than 0 and the reaction is called as exothermic reaction. An example of exothermic reaction is combustion of methane, in which 1 mole of methane gas reacts with 1 mole of oxygen to form 1 mole of carbon dioxide and 2 moles of water. For this, the enthalpy change is minus 890 kilojoules per mole of methane reacted, which means the combined energy of all the products is lower than the combined energy of all the reactants by 890 kilojoules.